Energy is zero. I look all around. There's lots of energy everywhere. How can you say that the energy of the universe is zero?
Well, let me take you back to one of your favorite times, high school physics, okay? So I throw a coin up in the air, it comes back down. I throw it up faster, goes a little higher, comes back down. If I throw up really fast, it doesn't come back down at all, as long as we forget the roof and all the rest of the stuff. Well, we teach high school students one way to calculate that. We turn it into accounting. It turns out the energy of the coin has a positive piece, we call it the kinetic energy, and a negative piece, which is the potential energy due to gravity. It's actually negative. And we add those two pieces up, and if you make the positive piece big enough, so the total energy is positive, it'll escape without coming back down. If the total energy is exactly zero, where the positive energy from the speed is equal to the negative energy from gravity, then it'll just escape. It'll go up, slow down, never quite stopping. So you see, gravity has this negative piece. And if you can balance the two, the total energy can be zero. And in fact, what's amazing is it turns out, one of the things we've measured with in fact, one of the other great discoveries in the last 20 years is we've measured the geometry of the universe. Einstein told us that space is curved in the presence of matter. And one of the big questions of cosmology of the 20th century, in fact, was what's the curvature of the universe? Is it so-called open, closed, or flat? Flat being the boundary between a universe that closes on itself and one that's open. And it turns out that we've discovered the universe is flat, as we theorists knew for reasons we may talk about in a bit.
The Earth is not, but the universe is.
The universe is flat in a three-dimensional sense. It's not flat like a pancake. It's flat like it's the universe you always thought you lived in, where the X, Y, and Z axes are perpendicular and remain perpendicular. Well, what's amazing is it turns out in a flat universe, the energies add up to be precisely zero. The energy of every galaxy, all the galaxies are moving away from us. Hubble discovered that in 1929. Everywhere we look, all the galaxies on average are moving away from us. If you measure their speeds and then you work out the attraction, the two add up to precisely zero. An amazing discovery that confirms this notion that not only is the universe flat and mathematically beautiful, but begins to give this inkling that maybe we could come from nothing.
Okay, but let the record show you're talking physics, not English here.